Welcome back as we first discuss internal logic devices which you will encounter in most PLC ladder logic diagrams. Let's look at the PLC ladder logic diagram of our block sorting machine. Rung 1 contains a contact T1 and a coil C0. T1 represents the switching contacts belonging to a timer T1 called the end of cycle timer, and C0 is an internal relay coil. They are both imaginary, but they do exist and they do work in the user program stored inside the PLC. On rung 5 we see a counter CT1, and on rung 6 we find the output contacts belonging to this logic device. The counter, like the internal coil and timer, is also imaginary, but it does work, as we shall explain later. Now we're ready to work through the ladder logic diagram of the block sorting machine. We've used a typical data access unit so that we can view the state of the different registers. The user program has been downloaded into the PLC, and the PLC has been switched from program mode to run mode, which means that it is scanning the inputs and recording the voltage signal at each input. As it cycles through the user program rung by rung several times a second, it finds that contact C0 on rung 2 is normally closed, and since the internal relay C0 has not yet been energized, its contacts remain closed, passing power across the rung to the output coil Y4, turning on the stop lamp. This example shows us how the PLC uses an internal relay when information must be passed from one circuit to another, and that's the real purpose of these internal devices. Now it's time to start the conveyor, so we activate the start switch, sending an on voltage signal to input X0. On the very next scan cycle, the signal is transferred to an input register somewhere in the application memory. This process is called updating the inputs. The memory switch or bit representing X0 changes state from a logical 0 to a 1, and the processor takes the necessary action when it has read the contents of the input register. Let's look at rung 1. For the moment, our start switch is closed, sending an on signal to address X0, whilst the stop switch continues to send an on voltage signal to input address X1. So power flows through both these contacts, passing power along the rung to T1. The contacts T1 belonging to the end cycle timer remain normally closed, since the timer has not yet begun its timing cycle. The rung is therefore true, and power flows across the rung to internal coil C0, and it becomes energized. Inside the internal relay register, a bit changes state from a 0 to a 1, recording this event, and on its next scan cycle, the processor acknowledges this change and makes a decision. The start switch, X0, on rung 1 is latched on by the retain circuit consisting of C0's normally open contact. The stop lamp on rung 2 is then turned off when C0's normally closed contacts open. On rung 3, C0's normally open contacts change state, passing power across the rung to the output coils Y0 and Y1. The processor records these conditions in an output register somewhere in the memory, setting the state of output address Y0 and Y1 to a logical 1, which, via the output interface, switches on the conveyor motor and the run indicator lamp. Before we leave rung 1, notice that the stop switch has been entered in the logic as an examine on contact. This may seem to contradict the real world, since the stop switch is wired to the input of our PLC as a normally closed switch. Well, let's see what will happen if we enter the stop switch as a normally closed or examine off contact in the user program. The logic now looks for an off voltage signal at input location X1. And does it find that condition? No, because the stop switch is just sitting there sending an on voltage signal to the input. So the logic does not find the condition it is looking for. The rung is not true, and the machine will not run unless the stop switch is activated, which is not what we require from the control logic. As we explain the ladder logic diagram, it is important to remember that we use relay-based terminology when describing the operation of the circuits, because that's the way we understand power flow. However, as far as the PLC is concerned, these contacts and coils are only symbols, but the PLC knows exactly what to do in the logic when it sees a particular type of symbol. After the break, we'll continue with our discussions using the PLC ladder logic diagram of our block sorting machine.